Hi, everybody, and welcome to Lab 8 of CAD 2131 and CAD 1133. Today, we're going to take a little departure from our very heavy Proteus work to do a little bit of AutoCAD. So today, we're going to be looking at uh, exporting 3D models. We're going to be looking at exporting 2D models. We're going to be creating a hookup drawing so that we'd be able to show our customer how to connect our circuit board to the outside world. And hang in there towards the end. I'm going to show you a new feature of Proteus where we can actually take an AutoCAD drawing and import it into Proteus for things like uh, 2D graphics or custom footprints that require something a little bit more sophisticated than Proteus used to be able to do. All right, let's dig in. One of the great things that Proteus can do is allow us to export a 3D model. And you might ask yourself why you would want to do this. And the answer is quite simple, actually. We would want to be able to export this for the mechanical design. Being able to import the CAD into our 3D design means that we can provide enough room, enough clearance, and everybody can understand where the connectors are, or where the displays are and buttons, and it makes life a lot easier. You may also want a 2D representation to be output as a CAD file so that you can bring it into other software like AutoCAD or Adobe, or even as a Word document. We'd be able to import some 2D rather than using a screen cap. One of the things that we need to be really aware of when we export 2D CAD is that we only export the items that we need. Here you can see an example where I've exported everything and it's created a huge complicated mess that's going to require a lot of time and effort to clean up. So when we do get into actually exporting this, be aware of what we're exporting and if we really need it. So you can see an example here where I've exported our project as a 3D file, and you can choose to export it as a step, as an IGES, or as an STL file. Be aware that a AutoCAD, depending on your version, may not be able to import an STL file, but you're definitely good with IGES or step. Okay, let's practice exporting a file now. So what we want to do is we want to go to the output. We want to go down to a generate MCAD, not the export graphics, but the generate 3D mechanical CAD file. And from here, we can choose what file format we want. So I'm going to choose IGES today. I'm going to call this 2020 Project 1. I'm okay with that. And I'm automatically going to open the output folder just because I want to take a quick look at it. So I'll say generate. And this may say that there's some problems. One of the things that we can run into is when we start importing CAD, you may end up with an issue here. And so you want to make sure that the mechanical models are actually attached. All right. So here we go. It's opened it up, and I should have. There's my IGES file. So let me open up AutoCAD here real quick. Okay, so we're going to import. We're going to browse to our file. Okay, now we can actually choose the IGES file. And of course, this process is kind of old hand at this point. And here we go. A reasonable example of our project. All right, so let's try the 2D next. Okay, so now to export the 2D graphics, we're going to go into Output, Export. We want to go to a DXF file. Okay, and now we want to choose the files or the layers that we want or don't want. And in this case, perhaps we don't want the top copper and bottom copper. Perhaps we want to keep the silk. We want to get rid of the mechanical layer. And Let's try the top resist. Don't need the bottom resist or paste, but we will keep the board edge. And let's see what this outputs. Okay, so we'll say uh, okay. And now if we go back to that file, there should be a DXF file there, which sure enough. And we have something reasonable. I mean, it's not perfect, but it at least shows our board edge and shows us where most of our components are. You'll notice the one thing that's missing is something that we would probably want, which is the holes. So perhaps we want to keep the top copper because that's going to show the holes, and go from there. All right. For your homework, I'm asking that you actually create a couple of drawings for me. One of them would be something similar to this, where we are showing all of the hookup points. And so, for example, we have a display, which I just went on the internet and found an LCD display and pasted it on here. Our programming header. Again, I went to the Microchip website and found the an image for the hookup. RS232 information so that we can tell the customer how to connect this. I created a little 4x4 matrix and so on and so forth. And the idea is that this can go with your PCB to a prospective customer or client, and you can explain to them very easily how this board is connected and used. The second drawing that I want you to make is a mechanical drawing. So I want you to export the 3D CAD, bring it into your file, and nice board edge and title block, and give me the dimensions. I don't care which dimension style you use, but I would like dimensions on it of how you would actually fasten this down. I also have a few additional parts for you to add to your bill of materials. One of them is a power supply. It would be really good for you to be able to power your board from a wall wart. And so here I've included the one that I've used, but you're absolutely free to go pick one that you want to do yourself. The other thing is that we have a header on there, that 2-pin connector to bring the power in. You're going to need to add a couple pieces. One of them is the connector, and the other are the little terminals that go inside. Let me show you what they look like. Okay, for on the board, we have this sort of connector, and these guys are great. But on the other end, we want to connect to the wire. We want to change the plug out. So right now that power supply will come with a barrel connector. We'd like to change it to this style that would snap in. Okay. Now the idea here is to give you some experience working with these sort of connectors because they're not as intuitive as you might think. One thing that you'll need for these connectors on the female side is the actual terminals. And so that's why it's important to get two pieces of the SVH21T-P1.1, which will go with the other components. And so I want you to get familiar with ordering complete sets of connectors and thinking about, well, I have the male, I have the female, and I have all the contacts. Okay. Okay. The next thing that I want to do is talk about clarification of some parts. Okay. So here I'm on DigiKey. I'm searching for parts. I'm looking for an encoder, and there's certain things that I know that I want. So I thought I'd take you along for a little search here. Okay. So one of the first things that I want to do in my parametric search is I want to make sure that it's normally stocked and in stock. There's no sense in picking something that I don't have. Now, the one that I'm looking for, I know that it's Borns, so I'll select that. And you can see that our selections start getting whittled down rather quickly. Now, I know that it was a PEC, and I believe, or it was a PEC 16, and automatically we're down to about 16 items to choose from. And now we know that it has a built-in switch, and we want a detent, and it's vertical. Okay, so now we're down to three choices, and we can choose whether we have 24 steps, 12 steps per. The cost is all the same, so why not go for the 24? And so this would be the rotary encoder that I would pick. Okay, and so again, we can take the manufacturer's number, not necessarily the supplier's number. You'll notice there, in this case, there isn't a huge difference, and we can uh, copy that out. Okay, there we've imported our encoder into my presentation. That's fantastic. The other thing is that I have a biasing diode. This is not really a biasing diode, it's a protection diode. And so the input for the 3.3 volts, that auxiliary one, what this does is make sure that if you hook it up backwards, it will actually short something out and freeze your power. Your like should put your power supply into overload. Um, this is a very lazy technique, but it does protect the rest of the circuit, although it may blow a fuse somewhere. That's okay. I also want you to make sure that you include some connections for the in-circuit programmer and for the display. So what we're calling M1. Make sure that they are included for your year one variant. Some additional parts that you can order for your year one variant, depending on how ambitious you are and how much you think you're going to use this over the summer. One of them is a programmer, and we have a couple of variants of it. We have the Picket 4 and the in circuit serial programmer called a Snap. Now, there's there are differences. This one's quite inexpensive, and this one is reasonably expensive. This is about double the price. Uh, but what this allows you to do is not just program your boards, but it will allow you to debug them and power them, and a lot of very powerful features uh, as a full programmer. Whereas the Snap here will only really work as a low voltage programmer. It can do some debugging, I believe, but is much more limited in its capability. But it's only $35 instead of $75 or $80. Be aware of that. Uh, Displays, there are a plethora of displays available to you. Uh, this one that I've given you, I haven't tested necessarily this particular one, but any I2C display that runs at 3.3 volts, you should be fine with. It's just a matter of writing the library or finding the library. Keypad. Now, if you are going to put in the keypad, know that you do need to put in the I/O expander and the header and uh, the resistors. Okay, so if that's something you want to do, you can go ahead and order those. The Pro Micro is another feature that you could pop in if you're familiar with programming it in the Arduino IDE. You can absolutely grab that, toss it in. Make sure that you remove the microprocessor chip, the PIC, from the board when you're running the Pro Micro, so the pins don't end up fighting each other. If you happen to have one program to do something and the other program to do something else, you could end up with a conflict that you could damage one or both of the devices. Whenever you have the opportunity to put in a socket, especially on a development board, absolutely do that. Um, there's very few times that you'll wish that you hadn't have put in a socket, but should you make a mistake while soldering, being able to remove a socket as opposed to an expensive IC is definitely an advantage. As a matter of fact, with things like a 28 pin DIL package, if I have a socket in there, I may not even try to remove it discreetly, I may actually just take the side cutters and cut it off and remove each pin individually, as opposed to trying to desolder each pin. That that's for inexpensive parts like a 7400 series, or uh, even a microprocessor. I might decide to cut the pins off that and remove them as well, just as a time savings. But if it was an irreplaceable ROM on your Lisa 2 computer that you're trying to restore, you're absolutely not going to do that. So one of the reasons back in the day that they would socket all of those prom chips so that they could actually remove them. So keep that in mind. Don't start by soldering the most complicated part on your circuit board. Start off with the simple stuff and move on from there. Also remember, solder the shortest parts when possible. Okay, so for me, I mean I solder all my SMT parts first, and pretty much do the really big stuff like a heat sink at the end, if possible. If you're putting it in the reflow oven, that's another situation altogether. But know that you need to be able to get in at the small parts to be able to place them and then work your way up. But part of this is going to be becoming familiar. Obviously, the little SOT23 package is going to be more difficult for somebody that's learning, as opposed to a DIL or double A inline package. One of the things that we want to do when we are testing a circuit board is we never want to just power it up and fire our voltages down the rails at the sensitive pieces of electronics. So what you want to do is check for dead shorts on the power supply, okay, between VCC and ground. If you don't have several ohms of resistance, you know there's a problem. And so one of the things that we can do with our circuit board is remove those jumpers, check it, make sure that your power supply is good, and then power it up. If you don't have 3.3 volts, stop and troubleshoot the power supply. Once your power supply is good and you don't have a short on the uh, microprocessor side, then you can put the jumpers in and try to power it up. Should your power supply then be good, we can try to program it. All right. So that's it for the lecture today. A fair bit of homework. It doesn't seem like it, but once you get into it, you're going to find that it actually does take some time to work your way through. Now, this 2D and 3D homework, I do want as part of your capstone project. So be aware of any feedback that I give you. You're going to want to modify it and put it into the package for your final presentation. All right. Right, our bonus bit of information. So Proteus has recently given us the ability to not just export a DXF, but we can now bring it in. Previously, what we would have to do is we would import a bitmap file. Okay, and that was great. I used to use it for company logos and what have you, but now we can actually import some real CAD. And one of the things that you'll find is Proteus struggles a little bit with creating some complicated geometry. For example, if I had something, let's draw a Pac-Man, for example. Here we go. And so here's my Pac-Man, and I'm going to put him on a layer called top, just so that I only bring him in. And we'll do a little save here. I'll go back to my Proteus. And so let's say this is something that we needed. It could be on the top silk, or it could be in the copper. We can now import this directly um, into our design. So here we go, top, and I'm going to actually bring this into my top copper. I'll say okay. There we go. And so this is a fantastic way to to actually do something that Proteus won't really let us do, right? And so do note that it brings it in line segments. So DXF, that's the way DXF files work, is they're actually just um, vector based files. So it's picking 2 points and saying this is a line between them. Okay, so nothing magical about a DXF file. But the great thing is that I can now bring this in and manipulate it. All right, have fun with it. Get the homework into me. I'll give you the feedback, and as always, I'm here for you. If you have any questions, comments, or suggestions, I really implore you to send me an email so that you don't end up falling behind, because we are getting really close to your final capstone project delivery day. All right. Thanks, everybody. Talk to you again soon. Bye now.